So let me just remind you that everything that you need to manipulate a list, a linked list, is available in list.h, which is a file that is yeah, yeah, that contains almost all the uh, implementation details of linked lists. And well, with that simple file, you can abstract and basically build a linked list from any struct that you have by just adding the struct list head to your code. So you typically also want to find the parent or an entry point to your linked list, and there is a macro that has been implemented for you to help you to do this, and it's called container of. And sorry, and basically the macro can easily find the parent structure containing any given member variable. And we are talking about general structs that we are not really sure what they will be like, so they can be Fox in our case, or they can be something else. So they're pretty general, right? And then you basically uh, have the container of being able to return to you the parent structure. Sorry, sorry. Uh, the parent structure able to return the structure, well, able to return to you the parent structure containing any given member, because in C, the offset of a given variable into the structure is fixed at compile time. So using container of, we do not really use that macro in our code, but we use either list head or list entry. I unfortunately have cut the wrong part of the code here, so both of them are list entry, but you can actually go to list.h and also look at list head. And list entry basically gives you uh, returns to you basically the parent structure containing in a list head. So it's I mean, using list entry, you can get the list head using the container of it. Just it's a wrap around the container of macro basically. And armed with list entry, the kernel provides you with routines to create, manipulate, and otherwise manage linked lists, all without knowing anything about the type that you are actually managing, right? It can be Fox or it can be anything else. So to initialize the linked list, you will have to initialize your first node in the list, and that will be your first Fox struct that you ever initialized. So this initialization uh, needs to be done before you use it the first time, because most of the elements are well created dynamically, so you do not have them already. And the most common way to do this initialization looks like this. So you initialize your Fox struct, and you basically call it red Fox. You allocate to red Fox enough memory basically to hold a Fox structure, and using the red Fox that you start filling up the different elements in the red Fox. So tail length, weight is fantastic, but you also initialize the list head. And since this is your first node, you initialize it to point to red Fox also. There are ways to initialize this if the structure is statically created at compile time, and you have a direct reference to it. And well, it's basically yeah, it's basically initializing a static structure in C. So with this abstraction, you can actually turn any struct into a linked list. And this is very powerful because any struct that you can come up with can be turned into a linked list. And in that case, well, your elements will be different. Well, your nodes in the linked list will be different structs, which you will basically be working with. You will have the first node as a head pointer to the list, and well, that's cool. But you also need to initialize a list head. You need to define a list head, and that's done using this called static list head and parenthesis fox list. So this will be your linked list name. It's called fox list now. And well, the fox list here is, I mean, is the name of the linked list that you are going to work with. Uh, and this you would typically do within your to basically initialize the list head, and then the majority of the linked list routines will accept your initialized linked list name as the header, as the head node, and based on that we'll do stuff. So let's look at, for example, list add. And list add is the uh, is basically the function that you use to add things to your list. And as you see, you pass to it a list head for the new one, and you pass to it uh, the list head of the actual old linked list. So this is at new is new entry to be added, and at head is list head to add it after. So you basically this is a pointer to the list head in your linked list, and this is what you get actually from this call, list head fox list basically. So this is your header. So similarly, you have a list add to tail, for example. So you add towards the end, add a new entry, and you have the new entry to be added, and basically list head to add it before. So you basically add it before the head, because you have the head nodes is the first node in your linked list, or supposed to be the first node in your linked list. But then if you add it before, then you're adding it to the tail actually, because this is a circularly double linked list. Okay, so uh, let's look at, for example, list add to tail, and you would basically have the fox list that a pointer to the fox list that you have defined as your list head using this call list head fox list. So you define this as your head node, and basically add to it the new fox that you're going to add.